Hello, I'm Marc Desgroseilliers from Technical Support here at Pix4D, and today I will talk to you about quality assessment. Now, this is a very important topic. We get a lot of requests about this, and the question is, how can I make sure that my project looks good and also is accurate in Pix4Dmapper? So we will go over 4 different methods to make sure that your reconstruction is good. The first one is visual inspection. That just means you generate the first step of your project and then you navigate the point cloud a little bit. You make sure that the features are where you would expect them to be, that your model is not curved down or curved up. For example, in the image that you see here, if you look closely, you will see that the buildings are slanted. So clearly, something went wrong, and so you need to look into it and fix it to make sure that you have a good project. So it could be because of the imagery, or it could be because of the camera parameters, but these are just 2 examples. I said that you would need to process the first step, but sometimes it's a little bit hard to tell. And what you can do is you can also densify the point cloud in the second step. And you can see here on these images on the left, it's kind of hard to see what's happening, while on the right, you can see that there are patches which are not correctly aligned. Presumably this field is flat, and so you have some issues in this particular project. The second way to assess the accuracy, and maybe the first tool that you want to use, is the quality report. And you want to analyze this quality report and make sure that everything looks good. This is the first table that is in the quality report that you can see. Here it will talk about the number of key points per images. So for example, in a typical RGB project, we would like this number to be at least 10,000. And it will also talk about the number of matches, things like this. So as you can see on the right, you have these green check marks. And here, if you have a red check mark, then this is a red flag. And what you want to do is you want to inspect this aspect of your project. One thing that could be helpful is we have a nice support article, which is called Quality Report Help. So it will help you troubleshoot each and every one of these sections. Maybe one last comment is here you can see you have a yellow check mark in the last row, and that is because no 3D GCPs have been used. But of course, you can get very good projects without 3D GCPs. So if you don't have 3D GCPs, then you shouldn't worry too much about this yellow check mark. However, if it's red, maybe you want to have a look at this Quality Report Help support page. We have a few graphics in the quality report that help you get a quick overview of your project and maybe some regions where you might have problems. The first one is this graph here, where the blue dots are the original camera positions from the GPS data, and the green dots are the optimized camera positions. And as you can see on this graphic, they match very well. So that's a good sign that tells you, okay, great, these 2 pieces of data fit together well. So that's a good indicator that your reconstruction is good. What you don't want to see is something like this, where the red dots represent uncalibrated cameras, and the difference between the blue dots and the green dots is a little bit all over the place in all sorts of different directions. So that's not a good sign. There's another graphic which will help you estimate the overlap. As you can see here, you have your whole project, and then for each region, if at least 5 images can see this region, then it will be colored green. And nicely homogeneous green is what you're looking for your project. So for example, this is a project where I would have a little bit less confidence in. So at the top, as you can see quite some yellow and red, and so I would be less confident that the reconstruction in the top part of the project is good, and I would inspect it more closely. We also have the 2D key point matches graphic. Here, every image is going to be a vertex, and we're going to draw a line between two images that share a key point. So what you want to have is a nicely connected graph, which is quite dense, and you can see here there's a lot of black, so that means that there are a lot of edges. This is quite good. What you don't want is something like this here, where you have several blocks. The blocks are color-coded, and here you can see there are not enough matches between the different images. And there are some blocks that are independent, and then they could be oriented in the incorrect directions. One of the new features of version 2.2 of Pix4Dmapper is the addition of uncertainty ellipses. Now, what this will do is that it will draw an ellipse around each camera, and the uncertainty is the size of the ellipse. So a bigger ellipse will mean that the software is less sure about this particular camera position and orientation. One important thing to keep in mind is that these ellipses, they have a magnification factor which is displayed below the graphic. So it could be that these ellipses, they're magnified quite a lot, and so you have some ellipses that are bigger, but if they've been magnified by a large factor, then this doesn't mean that your project is not good. It just means that the uncertainty is higher in the regions where you have bigger ellipses. So then what we would recommend is to inspect this region and make sure that the reconstruction in this region is good. So it gives you some kind of areas to target for inspection. And how are you going to do this? Well, this is the third way that I want to discuss, and it's projections in the rayCloud. So what you can do is you navigate in your project, you click a 3D point, and in the right sidebar you will have all the images that project onto this 3D point. And there will be a green cross that will correspond to the pixel that projects onto this, this feature that you clicked in the rayCloud. And what you want to have is you want to have this green cross always pointing to the same feature as in the images image that you see right now. Here is an example of something that didn't go so well. You can see that the green mark is on different features in the different images. And so then that tells you that you want to fix your project. Something went wrong. And in this particular case, it was the camera parameters that were not adjusted properly. The last thing that I want to mention are checkpoints. Checkpoints are very similar to ground control point in that they are features in your project that have precise geolocation data that has been captured while you were flying your project, for example. So now you've got geolocation data for this. You're going to click it in the images, much like you do for a GCP. The difference is that the software will not use this information to reconstruct the model. What this means is that when you have a GCP, it will help the reconstruction of the model because the software will try to fit the data, the GPS data, to the point where the 3D GCP is. So it will help the reconstruction. On the other hand, when you have checkpoints, the mapper will ignore this information and will do the reconstruction as if it didn't have this information. Now, what's the point, you might ask? Well, what it will provide you is an unbiased estimate of the accuracy because the mapper didn't try to fit the point, it just ignored it, and so there's no bias involved. Okay, that's all I wanted to say about quality assessment today. I hope you found this helpful, and I'll see you in the next video.